hypocritical. You took off points in my other course when I put a decimal and wrote equals, and it was actually not supposed to be that. That's true. And here I am merely Mr. Cook. In that other course, I'm Dr. Cook. So I have different, I put on different caps. I grade them differently. That is true. I will admit it. There's that one. Part B. So that was A. So the range on the Sea of Tranquility is what? The same physical analysis goes through we did the other day, but now you got to put the moon's gravity down here. So everything we did to derive that formula is still valid. It's just it's for a different G. G is equal to 1.6. I reject this terminology. G moon is 1.6, so you just put that in here. And what do you get? It's about 6.77 kilometers. This, by the way, was 1.07 kilometers. Okay. By the way, I do assume you guys can do unit conversion. I never really taught that to you in here. That is an assumed prerequisite of this course. That may or may not be a reasonable thing for me to assume of you, but it is nevertheless something I assume of you. Sorry about that. Some of that is dealt with in chapter 1, so if you've read the book, you should be up to speed. And I've done it in here a few times, right? Like we multiply by 1 in some kind of crafty way to make the units become what they should be. I know personally I learned that in college physics when I took it at community college. I think that's really where I learned the unit conversion. But is there another question? Yeah. Oh man, you're gonna make me work. So this is the balloon problem, huh? So, what?
Yeah. It's the acceleration of the particle.
Number what?
7.
Really? Oh. I didn't think that happened. Okay. Well, I'm confused. I thought that the problems had a... Well, all right, fine. Maybe I have a printout of... You know, guys, I picked out about like 150% of the problems I assigned you, you know? And then I cut it down, and that's what you actually have to do. So it could be that I have a printout of the larger problem set, which I didn't actually assign to you. Maybe that's what's going on. I don't know. Oh, well, this one's easier. Thank you. So you have the acceleration of a motorcycle. Number 7 for me is the balloon one. Did you guys have a balloon one? You got a balloon one? AT minus BT squared. And you're given values. A is what? A is 1.5 meters per second cubed. B is 0.1 meters per second to the 4th. And we're also given that x of 0 is equal to 0. And we're also given that v of 0 is equal to 0. Because it says it's at rest at the origin at time 0. We're supposed to find the position and the velocity as a function of time and then calculate the maximum velocity it attains. All right, so let's do it. A is dv dt. So that tells me that v is equal to 1/2 at squared minus 1/3 bt cubed. And that is, you know, I could say, okay, plus a constant, but v of 0 is equal to 0, and that's also equal to the constant. So therefore, v at time t is indeed 1/2 at squared minus 1/3 bt cubed. I really prefer to give it that way on the test, because if I give you numbers for A and B, it just clutters it, right? So of course, to actually find the answer that WebAssign wants, you got to put this 1.5 into here and this 0.1 into there and so forth. How about x of t? V is equal to dx dt, right? So integrating gives us x of t is 1/6 a t cubed minus 1/12 bt to the fourth. And that's it, because again, x of 0 is 0, so the constant works out to be 0. That's the position as a function of time. That's it. Any questions about that? I mean, so in...
On the homework, or this one, it said on the initial velocity that it has the same x coordinate at t0 and t2.6.
Which problem are you talking about? That's not the problem I have. Oh, that's my problem 9. This is very confusing. I'm sorry. So you were fine with this one.
Yeah.
Let me just, since I started it, how would you find the maximum velocity here?
Maximum velocity?
Yeah.
For the acceleration, 0.
Okay. Why would you say that?
That's when the velocity peaking.
Right. So it's when the derivative of the velocity is 0, right? So that makes it a critical point. So by like calculus 1, that's a maximum, right? Well, it could be a maximum. We don't know. So you're exactly right. So we just say acceleration equal to 0, and you work that out, right? So it gives critical time, and from that we get max velocity, or we get minimum velocity. I don't know without further analysis, right? Of course, you could look at the acceleration prime, which would be v prime prime, right? And that would be equal to a minus 2bt. And you could take these critical times and you could plug them into this formula. If it's positive, it's a minimum. If it's negative, it's a maximum by the second derivative test. So this is a maximization problem. We have calculus 1 to do it. All right?
Couldn't you just know that it's a maximum and not a minimum because you have an inverted parabola from negative b squared?
That is also true. Indeed, indeed, indeed. We do know things about parabolas. We can solve them with or without calculus. That is a legitimate comment. I will agree. So the problem you were actually trying to ask me about was my number 9. And we're given the acceleration of a particle. For me, it's a of t is minus 1.8 meters per second squared plus 2.7 times t. Something like that, right?
Yeah.
And then we're asked, find the initial speed, find v naught, such that the particle will have the same x coordinate at time 4.5 as it does at time 0. Ooh. That's kind of fun. So here we go. V of t is minus 1.8 t plus 1.35 t squared
Professor,
plus v naught. Yes, sir.
would this be a good equation to like call it a and b so that way it doesn't get cluttered and at the end it's plugging in? Just say call it a negative 1.8 and b 2.7.
Oh no, I mean we could, but I've already got a number. I don't. You could do that, yeah. I think we'll be okay though. So what is it legitimate for me to put v naught here as my constant? Is that reasonable? Aha, I better work quick. Yes, because if we put in times 0, we get back v0, right? And then what's x of t? Well, x of t is equal to minus 0.9 t squared. What's 1.35 divided by 3? I don't know. What do you got? 0.45? Be careful there, otherwise you'll get the wrong answer. But 0.45 t cubed plus v naught t, right? Plus x naught. And again, it's reasonable to put x naught here because if you put in times 0, you get 0 plus 0 plus 0 plus this constant. So clearly this constant has the meaning of initial position. All right. Now I have x of 4.5 is equal to, of course, x naught is x naught. No. So x of 4.5 is equal to minus 0.9 t 4.5 squared plus 0.45 times 0.45 cubed plus v naught times 0.45, right? Plus x naught, right? What happened? Oh. Yeah. I'll do that. Sorry about that. 4.5. It's unfortunate that we had that 0.45 constant come up in the formula. One more?
No, that's supposed to be.
Yeah, I know, right? Exactly. And that's equal to what? X naught, right? Therefore, this has to be equal to 0. Which means you can solve for v naught. You got the initial speed, and then you can answer the other question once you know that. So it's just a question of faith. Do you have faith in algebra? Can you work things symbolically, or do you absolutely need numbers to start with the problem? You don't need numbers. You have to be able to work both symbolically and, numerically. This is physics. I shut up. I will see you. Oh, that's right. Next time we have classroom interaction. Right? The highest form of classroom interaction, the test. Everyone's involved, right? We should have a test every class because you guys like interaction. No? No one agrees to me when I say this.